So now we get to dig into why Protopia is so essential. And the idea is that when you are using third-party LLMs,
Hmm.
huge amount of power, you want to take advantage of the absolute state of the art in a lot of circumstances, or maybe a more compute efficient option. But you might want to be able to switch between vendors, and your clients and you want to be assured that that your data are secure.
Hmm.
And with solutions like Protopia, that's possible. So we're going to spend the whole episode talking about this basically, and it's going to be fascinating because you can get really into the technical nitty gritty.
Looking forward to doing that. And I think one thing to quickly kind of broaden the scope of what we're doing at Protopia is that, yes, it is accurate based on what you just described, that it's applicable to large language models and helping kind of this idea of protecting data when the models are being run on third-party systems. But it's not necessarily just about third-party systems. It's generally focused on whatever system is the most efficient for either a large language model or any other machine learning model for that matter. How can you minimize the exposure of data while you're using those models? So zooming out just a little bit from only LLMs or third party, the topic of data exposure in machine learning has always been a challenge, and would love to get into that.
Fantastic. We are going to. And so it might sound like you're one of the machine learning engineers or developers or maybe CTO of the company, but in fact, you're the CEO of the company.
Right.
You are just a highly technical CEO founder, which I understand a lot of investors love, and our audience certainly loves for sure. And so, yeah, so Protopia, thank you for broadening the scope there, in general, is a leader in data protection and privacy preserving machine learning. Let's talk about the name first, Protopia. This is a word that I recently learned in the last few months because I'm developing a TV show, and one of our working titles is Cracking Utopia.
Oh, wow.
And
Okay.
I quickly discovered
Mm-hmm.
that there's a number of interesting things here, which is that the term utopia means not place. It's a Greek for not
Mm-hmm.
place. And so it's designed to describe an impossible.
That's correct.
Yeah. Whereas a protopia, so this is kind of like maybe in episode 1 of this
Mm-hmm.
Cracking Utopia series, we'd get into, okay, we call this TV show Utopia because it's a word people know, a
Mm-hmm.
paradise on earth maybe,
Mm-hmm.
but it's also by definition unattainable.
Mm-hmm.
Whereas protopia is something that we can aspire toward.
That's right. And I love that you bring this up as the first thing, because as we go through the different aspects of what it is that we're doing at Protopia, hopefully it'll become more and more clear how that name fits, because this whole topic of how do we protect data on systems, right? If we were to consider some utopian version of that, there would be zero, absolute zero, not close to zero, absolute zero exposure at any time. But that being almost impossible, if not impossible to achieve, Protopia would be, how do you get as close as possible to that? How do you make it such that you are minimizing attack surfaces around the data as much as possible without bogging the whole system down in the nature of the impossible things that would make it inapplicable?
Bogged down data transfers are the dystopian nightmare everyone fears. Countless films have been created about it.
Mm-hmm.
No, it's true. I mean, it would be a nightmare. We expect our devices, when we're using any digital tool, we want everything immediately.
Mm-hmm.
And that's now interesting and you already broadened nicely there the idea of Protopia supporting any kind of machine learning situation. But LLMs, the initial one that I spoke about, they are often highly compute intensive.
Correct.
And so you have to wait around. And so performance is essential. And
Absolutely.
you wouldn't want a bottleneck around your data security. So
Yeah, I think there's this kind of expectation that anyone working in the space of data protection, data security, needs to set around what different axes of freedom they have to play around with. And one of those that is non-negotiable in kind of the world of machine learning as we see it today. Let's call it the world of LLMs and Gen AI as the current focus of this space. Latency of how quickly you are able to interact, especially when you're focused on inference, right? That becomes something that's a non-negotiable. You can't really go about building solutions that are heavily focused on protecting data, especially for inference, if you are making big impacts on the latency of the system, because then it just starts becoming prohibitive to what the original point is. And that's one of the tenets of what we build our product and solution around, is focusing on these system level requirements that are pretty common among every use case that anyone imagines for these sort of workloads. So yeah, that's definitely one of the major focuses.
Nice. Makes a huge amount of sense. I also want to highlight quickly that we didn't really define Protopia. We said that it's something that's attainable. And so my understanding of Protopia is this idea of iterating towards improvement. So, you talked about, you alluded to what Protopia means by saying utopia would be a situation where there's absolutely no data security risks and no latency as that happens. But, that's probably not ever going to be attainable. However, a protopia, this idea of continuous iteration and improvement. And so in the context of being able to access machine learning securely, efficiently, that's, I guess, the focus of Protopia now. But in terms of a broader term, it means, human quality of life on the planet improving, lifespans extending, healthier quality of life into later years, a sense of fulfillment, community, all the kinds of things that we dream of for ourselves and our the people that come after us.
Yeah, and if we were to kind of create some mapping of that definition, which would be Protopia on Earth into Protopia for AI and the data space especially, I think that iteration also has this aspect to it of, again, one of the ways that we look at this space is that there already exists a lot of effort and technology that goes into securing systems. And data security partially comes from the systems being secure. So the technologies that we build at Protopia, what we're focused on is also being complementary to this broader set of ecosystem technologies that are being built. And it's only with these different layers that you're able to achieve better and better protection of the data by way of, again, narrowing the attack surface at various different levels. Now, in particular, the part of the problem that we have been focused on thus far has been addressing the attack surface at the data layer by what we think of as a proactive approach to data security as opposed to a reactive approach, where instead of just relying on the system not being compromised, we ask the question, if the system were compromised, and that's more or less always the case that can happen, then how do you make it such that proactively, whatever it is that's on that system is of minimal use to somebody that may come across it, a bad actor, etc.
Yeah, and that actually was the exact context that Sol brought up Protopia in episode 781, where she talked about how Protopia, I'm assuming this is the stained glass transform solution, that it transforms raw data into a format that even if somehow somebody gets their hands on that, it's not going to be very meaningful to them.
Correct. The idea is one of utilizing essentially the fundamentals of machine learning models and the fact that machine learning models live in fairly large, often representational spaces. And so what we're taking advantage of is the ability to move around in that representational space in a manner that the underlying model that's dealing with that data still is able to make sense of the data. But given that there's essentially manifolds of representations that cover the same meaning to the model, now if you were able to know what those manifolds look like and started picking representations at random at runtime, now you're making it extremely difficult to follow moving target for anyone seeing those representations. And that's part of what stained glass is doing.